Um, Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do a code review with you. And what I wanted to do is I wanted to cover Chebychev's theorem. Chebyshev was a mathematician in Russia in the 1800s, and he came up with this theorem. And this theorem can be used across all distributions with regard to statistics. But what I'll do is, just to give you a little bit of background of Chebyshev. Chebychev's theorem. Chebychev's theorem estimates the minimum proportion of observations that fall within a specified number of standard deviations from the mean. This theorem applies to a broad range of probability distributions. Chebychev's theorem is also known as Chebychev's inequality. And the thing about Chebychev's theorem is it can be used across all probability distributions, whereas the empirical rule, which I'm going to be covering later on in another video, only covers like certain distributions, like bell-shaped distributions. So now that you know a little bit about Chebyshev, what we'll do is we'll go ahead and start on the code review for this theorem. The formula for Chebyshev is 1 minus 1 over k squared, where k is the within number and over the standard deviation, and k must be greater than 1. So what I did was, there's not a whole lot written about Chebychev's distribution with regard to Python, because what I wanted to do is I wanted to write a Python formula on how to calculate Chebychev's distribution, and there's not a lot written. And so because there's not a lot written, I had to sort of like devise my own formula based upon this formula here that we were given. And here is a website that I sort of used to help me to devise the formula, but it wasn't perfect. You can look on the website yourself and you can see that it wasn't perfect. But one thing the website did is it gave me a list of numbers that I could use as an example. So I used this list of numbers as an example, and then I decided to calculate Chebychev's theorem. I decided that the best thing to do would be to use 2 functions instead of 1. So I devised a function to calculate the within num, and you can see the within num is in k. It's the numerator. And then after I calculated the within num, then I calculated the Chebyshev formula. So this is my work. It's my calculation. I didn't get the work from anywhere because there's not a lot written about it that I could find on the internet with regard to Python. So I sort of had to make the formula myself. So all of these people who are experts in Chebychev's theorem, if I made a mistake in any way, please let me know. I'm certainly open to criticism. So the first thing that we did was we had to calculate the calc within num. We had to use that, and I had to create a function for that. And in that function, I had to calculate the mean. And so in order to calculate the mean, we go up here to the very top function here. It says formula to calculate the mean. The mean is the sum of terms over the number of terms. And so if you've been watching my videos, in a previous video I made a function to calculate mean. So def calc mean temp equals 0, for I in range 0 len x, temp equals temp plus I xi, and then when that for loop is finished, temp equals temp over len, return temp. So that's the function that you're going to need to calculate the mean. So you need that function in order to get the calc within num to work. So we do def calc within num x. It takes a string of digits. Mean x equals calc mean, which it takes in x, a string of digits. Print mean is, and then so it tells me what the mean is. And then small num equals mean x minus min x. Print small num is, so you get the small num. Large num equals max x minus mean x. And you go print large num is. And then this is something that I had to do because I wasn't sure exactly what to do, because the within num is only one number, but you have the large num and the small num. So I said within num equals small num plus large num, that's divided by 2. So your within num is 44. And it said return within num. So your within num is actually 44. And something's in here. It said return within num. Okay, so then after we calculated our within num, which in theory you could have done it all in one function, but I just decided to do it in 2 functions. So this is another example of how you can call up a function within a function. So now we got the define the function calc Chebyshev, and that takes in a string of digits. So std equals calc std x. So that takes the std function So here's your standard deviation. So you have to be able to call up this function called standard deviation in order to use the function calc Chebyshev. So this is the formula for standard deviation. And in order to use standard deviation, because standard deviation is just the square root of variance, you have to know the square root of variance as well. So we'll come over here to variance. This is the formula for variance. So you have to know variance as well. So you do def calc variance, mean x equals calc mean x. So the function will take in a string of numbers. Numerator equals 0, diff from mean equals empty brackets. For I in range 0, len x1, diff from mean append xi minus mean x. Numerator equals numerator plus diff from mean I squared. And then you say, when the for loop is finished, you say variance x equals numerator over len x, and then you print that. And then the function returns the variance. So we got our variance here. But then the next thing we want is we want the standard deviation. And the standard deviation is just simply the square root of variance. So we do def calc std x. X is your string of digits or string of numbers. variance x equals calc variance x, stdx equals variance x to the power of 0.5, and so that's the square root, and you return stdx. And so now we've got our Chebyshev's fit theorem. We've gone over the other functions that you're going to need to get this theorem to work. Def, calc Chebyshev x, it takes in a string of digits or numbers. stdx equals calc stdx. Print std is, so we're going to print the std. And for this particular instance, it's 2.76. Within num equals calc within num, so we calculate that. So your within num is 44. Print, and then we define the variable k. K is within num over stdx. Print k is, then you print your k. K has to be above 1 for this theorem to work. Chebyshev equals 1 minus 1 over k squared. And you go print Chebyshev solution. So your Chebyshev solution is 0.63. And so that's the solution to this theorem of 1 minus 1 over k squared. And you can see that we had to use a lot of functions that I have previously made to get this function to work. And that's it for the code review. And as I said, there's not a whole lot written on the internet on how to get it to work. So if there are any Chebyshev experts and they want to tell me that I did something incorrectly, then certainly let me know. The only thing that I got hung up on was the within num, because you have to have a large num and a small num, but it doesn't tell you what to do with it. So what I did was I just decided to take the large num and the small num, add it together, and divide it by 2 to get me the within num. So if there's a better way to get the within num, then certainly please bring this to my attention. And another thing that I did whenever I did the formulas, I put a lot of print statements in there so you can see exactly what the calculations are. But whenever you use this formula, if you want to remove the print statements, you're certainly welcome to remove the print statements, because it doesn't really matter. I just included print statements to show my work. But once you know that the functions are working, you can remove the print statements. You don't need them. So that concludes it for Chebychev's theorem. In order to get Chebychev's theorem to work, I devised 2 functions. One is calculate within num, and another was calculate Chebyshev. And I hope you enjoyed this code review. If you've got any comments, please let me know. This is the first time I've ever worked with Chebyshev. So if you've got a better way to do it, please let me know that as well. Thank you for the subscribers to my channel. If you like my video, please like, subscribe, and share. And I look forward to making more videos for you in the future.